Our solar system is a busy place. Planets orbit the sun, each following its own unique path. Moons dance around planets, creating a cosmic ballet that has been ongoing for billions of years. And then there are asteroids, the cosmic wanderers. These fascinating objects travel through space, often unnoticed, yet they play a crucial role in our understanding of the universe. Asteroids are rocky bodies smaller than planets that orbit the sun. They come in various shapes and sizes, each with its own story to tell. They are remnants from the early solar system, leftover building blocks that never quite became planets. These ancient objects have witnessed the birth and evolution of our solar system. Imagine them as space rocks, some small like pebbles, others as large as mountains. Their diversity in size and composition makes them intriguing subjects for scientific study. These celestial objects hold clues to the solar system's formation billions of years ago. By analyzing their composition and structure, scientists can piece together the history of our cosmic neighborhood. By studying asteroids, we can learn about the conditions and processes that led to the birth of planets, including our own Earth. This knowledge helps us understand not only our past, but also our place in the universe. But asteroids are not just relics of the past. They are dynamic objects that continue to evolve and interact with their surroundings. They also pose potential threats and offer exciting opportunities for the future. Understanding their trajectories and compositions can help us mitigate potential impacts and harness their resources. Join us as we delve into the fascinating world of asteroids, exploring their origins, their diversity, and their significance for humanity. From scientific discoveries to future space missions, the study of asteroids opens a window into the mysteries of our solar system and beyond. The vast majority of asteroids reside in a region between Mars and Jupiter called the asteroid belt. This belt is a vast, sprawling region filled with countless rocky bodies, ranging in size from tiny pebbles to massive boulders. This belt is like a cosmic racetrack where millions of asteroids orbit the sun. These asteroids follow elliptical paths, creating a dynamic and ever-changing environment. But how did this belt come to be? The answer lies in the early solar system's chaotic beginnings. During this time, the solar system was a turbulent place, filled with swirling gas and dust. As the sun formed, a disk of gas and dust swirled around it. This disk, known as the protoplanetary disk, was a hotbed of activity, with particles colliding and sticking together. This disk, called the protoplanetary disk, contained the building blocks of planets. Over time, these clumps of matter began to coalesce, forming larger and larger bodies. While some of the material clumped together to form planets, the immense gravity of Jupiter, the largest planet in our solar system, prevented the formation of a planet in the region that is now the asteroid belt. Jupiter's powerful gravitational pull disrupted the process, causing the material to remain as smaller bodies. Instead, Jupiter's gravity stirred up the material, causing collisions that fragmented the larger bodies into the asteroids we see today. These collisions were violent and frequent, breaking apart any larger bodies that tried to form. So, the asteroid belt is a kind of cosmic graveyard of shattered planetary dreams. It is a region where the remnants of the early solar system still exist, providing a glimpse into the past and the processes that shaped our solar system. Not all asteroids are created equal. Just like rock shapes, sizes, and compositions, so do asteroids. Astronomers classify asteroids into different types based on their composition and the way they reflect sunlight. The most common type is the C-type asteroid, which is dark and carbon-rich. These asteroids are thought to be the most primitive, meaning they have changed very little since the early solar system. Then there are the S-type asteroids, which are brighter and composed mainly of silicate materials and nickel iron. And finally, we have the M-type asteroids, which are relatively rare but intriguing because they are mostly metallic, containing valuable resources like iron and nickel. This diversity of asteroid types tells us a lot about the conditions in the early solar system and the processes that shaped these cosmic wanderers. While most asteroids safely orbit the sun in the asteroid belt, some venture closer to Earth, occasionally colliding with our planet. These impacts, though rare, have left their mark on Earth's history and landscape. One of the most famous impact craters is the Barringer crater in Arizona. This massive crater, nearly a mile wide, was formed about 50,000 years ago when an iron-nickel asteroid slammed into Earth. The impact released energy equivalent to thousands of atomic bombs, instantly vaporizing the asteroid and excavating a colossal hole in the ground. Another significant impact occurred 66 million years ago when an asteroid estimated to be about 6 miles wide struck the Yucatan Peninsula in Mexico. This cataclysmic event, known as the Chicxulub impact, is believed to have caused the extinction of the dinosaurs, along with many other plant and animal species. Section 5. The dinosaur's fate. The Chicxulub impactor. The Chicxulub impact was a defining moment in Earth's history, marking the end of the dinosaur era. This colossal event occurred approximately 66 million years ago when a massive asteroid, estimated to be about 10 kilometers in diameter, collided with our planet. The impact triggered a chain of catastrophic events that had global consequences. The force of the collision was so immense that it caused immediate and widespread devastation. The initial impact released an unimaginable amount of energy, equivalent to billions of atomic bombs. This energy release was so powerful that it caused the Earth's surface to momentarily behave like a liquid. It instantly vaporized the asteroid and a vast amount of Earth's crust, creating a crater over 100 miles wide. This crater, known as the Chicxulub crater, is located on the Yucatan Peninsula in Mexico and remains a visible scar on our planet's surface. The impact generated shockwaves that traveled around the globe, triggering massive earthquakes and volcanic eruptions. These seismic activities further contributed to the planet's turmoil. Trillions of tons of molten rock and superheated vapor were ejected into the atmosphere, causing widespread wildfires. These fires consumed vast areas of vegetation, adding to the environmental destruction. The impact also released massive amounts of sulfur dioxide, which formed sulfuric acid aerosols in the atmosphere. These aerosols blocked sunlight, causing a dramatic global cooling effect that lasted for years, plunging the Earth into an impact winter. This impact winter devastated plant life, leading to the collapse of food chains and the extinction of the dinosaurs and many other species. The aftermath of the Chicxulub impact reshaped the course of life on Earth, paving the way for the rise of mammals and eventually humans. Asteroids, a threat to humanity. The Chicxulub impact serves as a stark reminder of the destructive potential of asteroids. While such large impacts are extremely rare, even smaller asteroids can cause significant damage if they collide with Earth. A relatively small asteroid, just a few hundred feet wide, could devastate a city, causing widespread destruction and loss of life. The good news is that scientists are actively searching the skies for potentially hazardous asteroids. Using powerful telescopes, they scan the night sky, looking for faint points of light that move against the background of stars. Once an asteroid is detected, its orbit is carefully calculated to assess the risk of a future collision with Earth. Section 7. Space mining unlocking asteroid riches. While asteroids pose potential threats, they also offer exciting opportunities. Asteroids are rich in valuable resources such as water, precious metals, and platinum group metals, which are scarce on Earth. The idea of space mining, extracting resources from asteroids, has captivated scientists and entrepreneurs for decades. Water extracted from asteroids could be used to support future space missions, providing drinking water for astronauts and fuel for spacecraft. Precious metals and platinum group metals mined from asteroids could be used to build infrastructure in space or return to Earth to meet growing demand. Space mining is still in its infancy, but several companies are developing technologies to make it a reality in the coming decades. Section 8. Eyes on the skies. Tracking and deflecting asteroids. As we venture further into space, understanding and mitigating the risks posed by asteroids becomes increasingly important. Scientists are developing various strategies to track and deflect potentially hazardous asteroids. One approach is to use a kinetic impactor, a spacecraft that would collide with the asteroid at high speed, slightly altering its trajectory. Another method involves using a gravity tractor, a spacecraft that would use its own gravity to slowly nudge the asteroid off course over many years. These planetary defense strategies are still in the early stages of development, but they offer hope that we can protect our planet from future asteroid impacts. Section 9. Conclusion: Our future among the asteroids. Asteroids, the cosmic wanderers, hold clues to our solar system's past, pose potential threats to our present and offer exciting opportunities for our future. By studying these celestial objects, we gain a deeper understanding of our place in the cosmos and the forces that have shaped our world. As we continue to explore space, asteroids will undoubtedly play an increasingly important role in our future. Whether we are mining them for resources, deflecting them to protect our planet, or simply marveling at their beauty, asteroids will continue to captivate our imaginations and inspire us to reach for the stars.